So we might get started. So my name is Chris Berg. I'm CEO of DataKitchen. And before we start this webinar, I'll have a few things I want to share. The first thing is that the slides and the recording and the transcription, I'll put up a little website and I'll share it today or tomorrow. If you see on the right-hand side of Google Meet at the corner, there's a thing that looks like a chat window. And so if you have questions, put it in there. And I promise to answer them. I may answer them right away, or I may answer them at the end. And we've targeted 45 minutes, but most likely it'll take an hour for this presentation. So we're going to talk about three things. So we're going to start with an overview of testing and test coverage in data and analytic systems. Then we're going to kind of talk about the art of the possible to achieve test coverage. And then we'll give some design choices on how you can achieve test coverage. So first of all, kind of going from the beginning. So when you produce a report or a model or an extract or dashboard, we think of analytic processes like manufacturing. Materials, i.e. data, go through a series of steps, and the manufacturing stations are the tools that you go on, and you have an output, the data and the charts and the model. And however, analytic processes are also like software development in that you build something, usually on your desktop, and then you deploy it into production. And you've got, and both of those things have to happen together. And so we've written several books about this idea that you've got this, what we call the value in the innovation pipeline. And both of these things are often happening at the same time. You know, you're running something in production and you have a data engineer or a data scientist working on a new model or a change or adding a new data set. And so the thing that you want to avoid, and sort of why do test coverage, is number one, you don't want to learn about problems from your customer. You don't want them to say, hey, look, this chart looks weird, or this data is wrong, or I can't trust you, team. My data team, you're always getting data wrong. And then the second is you don't want to put something, you don't want to have that change to a model or change to some SQL break what's in production once you deploy. So you want to have speed and low risk of deployment. And so test coverage helps you with both, not breaking things, not having embarrassing efforts, and then not breaking things when you change it. And so where is test coverage? So I guess in this discussion, we're going to break it down into two buckets. One is what we call production test coverage, and that's in that value pipeline. That's in the data and analytics system you have in production. And then the second is in development, where you're making changes to that data and analytics system, usually code that you're doing, or it could be environment, or it could be new data sets. And so the idea of test coverage, and we'll talk about what testing is in a little bit, but that in the production, your code itself that's acting upon data is static, but the data itself changes, you're getting updates. And then in development, your data is static, you're using test data, but your code is changing. And so there are tests across all these parts. And often these tests can be the same. They can serve double duty. And so where is testing? So in your production pipeline, or sometimes we call it the value pipeline, you want to test every step and every tool in your pipeline. So you want to know that things have worked. So maybe you get some poor data from your data provider, or maybe you've joined that data to another table and something happened in the ETL process. Or maybe that joined data is being added to from a segmentation model, or that's being actually shown in some charts and graphs at the end. And maybe that didn't get loaded, or someone applied some business logic. So all these places are where you can find problems. And the whole goal of this, of having coverage, is to make sure that you don't find errors in front of your customer. Likewise, when is it? Well, we're going to break it into two parts and sort of shift left and shift down. And unfortunately, these terms mean different things in different contexts, right? And so I'm going to use them in our context. But the term shift left means executing data quality tests earlier. So if you find a problem in raw data, it doesn't get to your customer. So therefore, you have saved yourself time and effort. So finding problems earlier in production, that means shifting left, is a great benefit. Likewise, if you find problems earlier in development, you don't deploy them into production. So you shift down. And so these actually have different meanings in software development. Shift left is actually equivalent to shift down in our nomenclature. But we're going to use these terms kind of as part of the discussion. So we mean shift left means finding things earlier in production. Shift down means finding them earlier in development. Because again, you've got two processes going on that you have to get coverage for. So why shift down? Well, this is a chart that, if you come from the software world, makes sense. If you find problems earlier and they don't get into production, you have a multiplicity of cost savings, 10x, 40x, 640x, right? Defects found earlier. And if you notice this graph on the bottom right here, where it says coding, unit test, functional test, system test, release, these are levels of testing. And we'll talk a little bit about these words and how they apply to data and analytics systems. But if you shift down, i.e. you find them more towards the coding and unit test level, it's so much cheaper than breaking production and having to rebuild it or do something else. Likewise, there's a similar curve in shifting left, i.e. I find the problems in the source data or in the raw data. A very similar curve applies. And one way to think of it is the 1-10-100 rule. So for instance, if I find a problem at its source, that costs me $1 to fix it. If I find that gets farther, it gets into a report, that's $10. And if it's failures, it shows up in front of your customer, well, that's $100. And so that 1-10-100 rule applies here. Finding it earlier is better. And you notice these curves sort of look alike. But it's a very similar. Finding it earlier, shifting it left or shifting it down, it saves time, it saves money, it saves hassle. And so let's just define what test coverage is. So it's a term that there's test coverage in software. And so I'm using it in data and analytics systems. So I think it makes sense to define it. So we're talking about something where it's automated checks. And specifically, it means checking data that has been either the raw data or data that has been acted upon by some tool or code, like a pipeline, a model, a visualization, a transformation, an output. And so the higher the level of your coverage, the more confident you can be that the data you produce is accurate. And a lot of organizations kind of rely on spot checks or ad hoc or manual. And that doesn't give you test coverage. Having, your buddy look at it who happens to know a little bit about the business, say that looks right. And it's the same thing in software. And so I have some gray hair. I was part of the software industry back in the 90s when the way we tested it was the same way we test data and analytic systems now. Your buddy looked at it, you said it was good, you released it in the production, and then you were up at midnight fixing things. And so I still remember in 1997 being on a website with 3 million people, recoding it while they were there and kicking them on and off. And so we don't do that anymore in software, right? Every software system has automated tests against it. And so we don't do that in data and analytics. And so, and one way that software teams measure the amount of testing they have is test coverage. And I think that we need to have that same idea here in data and analytic systems. And so that sort of begs the question, what's a test? And so tests are automated ways to check for the correctness of a system. And so what that means, we're checking for the correctness of data, or we're checking correctness of outputs of data. And so tests are run in production and development automatically. And so if we think about production testing and development testing, obviously you want in production, you want to find the problems kind of before the fact, right? Testing is done as sort of part of the production process, because then you can stop it or and hold off production in order to find. And so you want to have tests sort of part and parcel of your production process. And well, what if you can't do that? What if you don't control your production process? Some other team runs the ETL. You're just a data quality person. Well, you can still do testing. You just do it after the fact, right? You can periodically test your database. That's good, right? You could catch it before you get to production. You still have the remediation, but it's better than what I think a lot of teams do, is you just sort of avoid the fact. There's no automated testing in production, and failures, the only time you know about failures is because your customers tell you about it. And a similar sort of trio happens in development, right? There's what I call dynamic testing. You're executing validations against real data and real code. And then there's another one called static analysis. You're checking the code or SQL for kind of syntax problems without kind of running real data. And then there's another one that I cheekily say is hope-based testing. You're no formal tests. You're kind of reliant on intuition, or you're having somebody look at it and they click around and go, that feels right. So kind of going into these production testing types. So we've got, before the fact, after the fact, and avoid the fact. So how to do before the fact testing? You want to be able to test every step of the process and stop it if necessary, and find the impact across all the production steps and tools. And so this allows you to find problems before your customer sees them. And you need to instrument your pipelines. And so we're going to talk about how to do that, or use a test-aware orchestrator like DataKitchen or Dagster or DBT, where the tests are part of the step-by-step process. And as the step is going through, you're checking and stopping. And then you've got to perhaps redo it or restart it. And so this way, the problems don't get into production. Or if you don't have a test-aware orchestrator, I think I'm not sure what you do, but that's part of it. Having tests across your tools, looking for errors from data, errors from tools failing, and then having a process that controls that. So after the fact testing, well, let's say you don't have that and you're just running it, right? Some other team's running the ETL process. Well, what you can do is kind of poll. You can kind of poll your database every 20 minutes, every hour, and look for failures. And then you use data lineage to actually be able to poke the team, the correct team that has the impact. So it's kind of a poll and poke metaphor. I'm going to poll the database and I'm going to poke people when there's problems. And the benefit is you don't actually need to instrument your pipelines. You just have this polling your database. The problem is you've actually allowed problems to get into production. And now people have to scramble to fix them. But at least you found them, right? It's better than the bottom, right? I'm just avoiding it and kind of I'm eyeing it up. I'm looking at it. I'm waiting for my customers to yell. And so these are the three different sort of categories or types of production testing. And then development testing. And I think these are, at least the first two are not mutually exclusive. So you want to catch real world failures at runtime. And that means integration tests, or what are called end-to-end tests. So I'm pouring in realistic test data. I'm running the system in development, and I've decorated that system with a bunch of checks across each step, across each tool, and I've got good coverage on it. And so that's dynamic testing, real data against a real system with tests in a development environment. There's another case called static analysis. And this is a case where I'm running tests as part of your deployment process. Like when you commit to Git and you are then have an integration step, you're what's called continuous integration, continuous deployment, CI and CD. There's different ways that you can do it. One is called linting, which is a syntactic way to look for incorrectness in the data. There's SQL Fluff, which is a linter. There's a DBT that's got a static analysis feature. And that's good. My experience with software is It's kind of nice to lint it. It happens fast. The same thing with unit tests. They're meant to run kind of like a snap of your fingers. And so what happens is I check something in and I run a whole bunch of quick tests on it. And so things like a Python, if you're doing your ETL in Python, there's unit test frameworks, but these are not enough, right? Another case is kind of things like what we call in data, a data hygiene test. I go in and look at a data file and look for kind of static, I do a static analysis of the problems in it. And both of these, I think, can be used together. I'm much bigger fan, like you won't be successful with just static analysis. You need to have dynamic testing. And obviously, hoping never works. So like, where should you do it? I think doing kind of, some static analysis is good. If you have to do it after the fact, but doing before the fact dynamic testing, that's where you get your most leverage and coverage. Where do people actually do it? Honestly, I think most people are kind of in the hope and avoid the fact. Most teams are. I think with some newer tools, people are doing after the fact. They're doing some static analysis. Like, to me, if you look at testing in the market, they say do data observability, which we're going to talk about as an after the fact type test, and then they're doing unit tests. But I think this is where very few people are actually doing, and I think that's where we should spend our time. So I've gone through kind of, what are tests, how to test, different test types, what teams are doing it. Now let's go to the measurement part. So test coverage has got you want to have a report saying I'm fully covered. So what does full coverage mean? What does full test coverage mean? So it should be in two parts. One is all the levels or zones in your database. So every data and analytics system I've ever seen has at least got two. I've got raw data and integrated data. There's the so-called medallion architecture where I've got raw data, kind of lightly mastered or cleaned up data, and then I've got integrated data. Oftentimes there's more. There's raw data, there's lightly mastered and cleaned up data, there's integrated data, there's customer focused data. I've seen L5s, L6s. It's crazy how often people are putting data in different places. But every table that you have, whether you have 2 levels or 6 levels, should have data quality tests on. And every column and every table should have data quality tests on. And every significant business metric, every kind of domain specific thing that you look at, maybe you're not in business, maybe you're in government, but like everything that you measure should have tests. And why is that? Well, somebody who is your customer will have memorized that metric and are looking for significant shifts on it. And then every tool that uses data should be checked for errors in timing, right? Because again, your data could be perfect, but your tool could have an error or take too long. So what types of tests? So every table should have what are called consistency checks. I'm looking to see if something changed. It's inconsistent from the way it was before. That's volume, freshness, schema. Every column in every table, I should look at it and then say, did something significantly change in that column? Volume, freshness, drift. And every business metric should have tests. Is it out of whack? Did it drift somehow? And then every tool as part of your system should be checked for errors in timing. You want to look in logs to see if there's an error. You want to check metrics. Maybe my database is at 95%. You want to check every task and substatus of tasks for errors, and then check timing and duration. So all these things have to be right to judge the correctness of the system. The data has to be right. The tools have to be right, right? And the tools tell us things like logs and metrics and task status and duration and start and end. Those things are, whether you call them tests or monitors, those have to be checked and have to be right so you can ensure the correctness of the system, so you have adequate coverage. So what are some rules of thumb? So every table should have minimum 2 tests. Things like, did it get really big or really small, right? Every column should have 2 tests. Every significant business metric should have at least 1 test. And then every tool that uses data, so that's a lot of tests there. So before I go on, that's a lot of tests, right? And so, but what's the challenge here in having errors? Again, it's that 1 to 10 to 100 rule. Having good test coverage is worth it because you're saving yourself time later on. And so, yes, you have a lot of tables. Yes, you have a lot of columns, but having adequate coverage is important. And then every tool that uses data should be checked for errors in timing. Sometimes there's 2, 3, 4, but you want to look for errors in your logs. Sometimes you want to check metrics. I guess that could be optional. You want to check every job for failures in task status. You also want to measure every tool and every job in that for timing and duration. So what's an example of that? So in the system here, it's a little bit hard to see, but there's sort of stream sets, Airflow and DBT, then Airflow and DBT again. There's an L1 database, an L2, and an L3. If you think about it, there's 3 database levels, L1, L2, L3. There's 3 tools, stream sets, Airflow, and DBT. And then there's 5 jobs to monitor, right? Let's take an example. Let's say L1 has 100 table with 10 columns per table. So you have a minimum of 200 table tests and 2,000 column tests. Now L2, that also has 100 table and 10 columns. So again, you have 2,000 tests. L3, it's got 10 tables because again, it's an integrated database plus 30 columns. So you get 20 table tests for 600 column tests plus a handful of domain specific business metric tests. And again, maybe it's more than a handful. I actually think these things are amazingly good. 3 tools. Well, I've got to check my tools for errors and 6 jobs, right? I've got to have 12 checks for problems. And so that's a lot of checks, right? And so having sort of thousands of tests that run across every level is certainly sounds like a lot to people. It's something that my company and I have been doing for decades. Tests are small, tests are fast. Having thousands of tests, I think a decade ago, we had a customer, we had 10,000 tests running against he had hundreds of tables, sort of 50 different data sources. And he loved to say that. He loved it. Every time a customer says, oh, this looks weird, he goes, well, we have 10,000 tests. Help me understand. And then the customer would say, oh, you have 10,000 tests. And so, yes, they have some computational cost to run, but it's so much better to have these tests. Not only from being able to say that your data team's awesome, but also finding problems earlier, saving yourself time, getting adequate test coverage. So here's the challenge here. Writing these tests manually doesn't scale, right? So we're going to talk a little bit about our tool in a bit, but let's say I'm a trade and data engineer. I've got 2,500 tests to write on 20 tables, 20 columns. I've got 30 minutes to do each test. That could take sort of 7 months to write all those tests. Now, that's not particularly bad, right? If you look at it, maybe 20% of your time is writing tests. I've said that many times. And as a software engineer, I've had this built-in bias that good software engineers write their own tests. And so, yeah, it takes some time, but it's always worth it. And I've sort of had this view that damn it, do your own testing. However, over the past several years, we've noticed nobody writes enough tests. And so we built this technology called TestGen that actually writes tests for you. And so now a junior operator can generate these 2,500 tests in just two button clicks. So this is like minutes instead of months. And so that's a really big sea change, I think, in how we can work. Not only because me being grumpy old software engineer, data engineer says, damn it, you should write tests, but now it enables you to do that very quickly. And also, and it tries to get you a whole bunch, 80% of the way there in writing all your tests. So think about it this way. How long does it take to run white tests for you? Do your engineers know what tests to write? How much is one customer finding one error going to cost you and your teams in time? So that sort of is the beginning, sort of an overview of testing and test coverage and data and analytics systems. We talked about shift left. We talked about shift down. We talked about the types of testing. We talked about how to count test coverage. We talked about testing in development, testing in production. Now let's look at what's possible and with our free open source tools. So we're going to walk through, the next part is sort of using those tools and walking through them. And so if there's any comments or questions, feel free to put them in the chat. I'm looking, I don't actually see any right now. And then when we get done with the section, we're going to talk about your design choices in test coverage. So we've got about 30 minutes left. So, so the first part is like, how do I get all these tests? Like, how do I get 80% there? How do I get 80% coverage? So our tool TestGen really is a way to sort of automatically get test coverage, automatically get consistency testing across all the tables and all the columns on tables. And so what it does is it learns the data, sort of enables you to have tests on every table and every column quickly and easily. And there are a lot of small, fast tests, and enables you to get broad coverage. So think of it like sensors or burglar alarms, where you're putting it on every door, every window, lasers across the front of the room that people walk in. But it does it in a smart way. It infers it from profiling data and from what we call semantic data types. And then it generates these tests. And so what it does is, the real key is deriving the right tests. So there's characteristics of the data that TestGen does. It's got 51 profiling characteristics. Part of that is developing what we call semantic data types. And then it takes those semantic data types and automatically generates the right tests for the right column. So there's a lot of smarts in here to be able to make that happen, from the profiling data and the semantic data types to automatically generate tests. And this is really good because it can help you get coverage. And I won't go through all these tests here, but like, here's the kind of test that it has. So the first one is freshness, like how to tell if you've got something new in a table or something new in a column, right? Or something wrong that's in there. And then there's volume. Well, there's volume in the table, but there could be volume in the records, right? There could be duplicate rows. And so this is, again, testing the data table itself, but the column itself for inconsistency in volume. And then lastly, or second to last, how do you tell if something's wrong in the schema if the data fits? Well, there's the schema, the DDL, but then there's what's in the data. Like, does it not fit the pattern? Is the format wrong? Is the address wrong? If when I looked at the data first, there was 1 million or records, there were only 5 different types of things. Did I get a 6th now when I got new things? So this consistency is really important. And then drift, like how do I tell if the data is sort of good enough? And this is like using sort of statistics like Cohen's D algorithm, the Z-score, to look at the shift in values, like percent missing, percent unique. And so they're using statistical methods to see if there's some drift based on the data. And so all these tests are really trying to say, press a button, give me 80% coverage across all my columns and all my tables. And a bunch of tests that computationally run in seconds or minutes. So that's what's trying to drive this get data test coverage across all your levels in your database. Now, we believe that it's not 100%. There's always going to be the 20% that's specific to your world, specific to your business. And I'm a big believer that these things are really important. Like I think of testing, like if I can find the right metric to test and I look at if there's some shift in it, that metric, that represents a whole bunch of stuff. So I'm a big fan of these tests, right? And they tend to be kind of very specific to your industry, like the number of medical practices shouldn't exceed the number of doctors, or there's no shipments on Friday, or sales of a product shouldn't increase more than that percent, as compared to last time. And they can be built by data engineers. And what we've done is we have templates and we've embedded statistical measures like the relative entropy comparison to look at 2 different ones. So we've got a bunch of these, what we call referential tests. They're sort of fill in the blank tests. And so here's an example of 2. One is called a reference match. So here's a case, like I want to look to see that one table's got a bunch of values, and then another table's got a bunch of values. And are they differed in kind, or in that these combination of values have shifted? And then here's another case of distribution shift using something called Shannon-Jensen or Jensen-Shannon divergence. So let's say I want to look at I've got shipments of materials per state and construction projects per state. Is that like I'm shipping a whole bunch to a state, but they don't have a whole lot of construction projects? That doesn't make sense. And so that's a way to catch the shift between those things. And again, is it states and construction materials? That has to do with your domain, but these are sort of quick, template-driven, fill-in-the-blank tests that you can run and then manage. And then one of my favorite ones here is what we call an aggregate balance test, or what I call a historic balance test. And if I look at sort of time one, and I see I've got volume 575, but I've got these product groups here, and one is 225, one is 350. Now, time two, the volume hasn't changed very much, 585 compared to 575. Yeah, that's good. These are pretty close. But this product group here shifted. And therefore, my aggregate balance is now 370 versus 215. That's a big change, 370 to 225. And I personally have been yelled at by these types of things, where a customer looks at it and goes, "This is wrong." And I'm like, "No, the data's right." He goes, "No, this metric is wrong. Our product group G1, it was 225 last week. Now it's 370 this week. Your data team's all idiots." So again, being able to build these things, looking at the tip of the pyramid, very specific to your industry, we help you do that quickly. And so I've talked a lot about our statistical methods. Now, so we talked about sort of broad consistency testing in data and domain-specific consistency. Now, your data in your database could be perfect. I've got coverage everywhere. You could still get it wrong. Well, how is that possible? Well, something happened with your tool. It took too long. It had an error and didn't get complete. The export didn't run. So the reports didn't refresh. So we have this idea called a data journey that's in our data ops observability tool. And that you've got lots of things acting upon data, your viz tools, your pipeline tools. Now, those things need to be checked. And so you've got lots of these data journeys in your organization with lots of tools. And what we're trying to do with this idea of a data journey is judge the expectation versus reality. Like, I've expected the data to be perfect and it to take 2 hours. It took 4 hours. I expect the data to be perfect and I expect the reports to be refreshed. They're not refreshed. So what's the variance between expectations and the reality? And so we think that this complements the idea of data lineage. So I think of data lineage as a blueprint of a building, right? And I think of data journeys as a fire alarm control panel. Now, something goes wrong. If I'm a fireman, I walk into a building, which do I look at first? Does he or she look at the blueprint or look at the fire alarm control panel? Well, obviously, they look at the fire alarm control panel, right? So data lineage, think of it this way. Data lineage shows where the fire might spread. So having the blueprint says, okay, there's a fire on floor 1, it may go up to floor 2 and look at this room above it. Fantastic. But data journeys with tests show where it's actually burning. So you could look at your blueprint, say, yeah, it could spread to the second floor, but is the fire alarm actually going off on the second floor? And so data lineage is kind of a guess on the impact, but complete test coverage shown in a data journey is clarity. And so data lineage may show 5 tables impacted, but if you've got test coverage on all those tests, you can see that it has only 1 error. So this is why we think this is a really exciting idea on how it complements the idea of data lineage. So this is testing in production. Broad automatic consistency testing, domain-specific testing, testing your tools during the data journey for errors in SLA. Now, testing it in development. So this is, again, we're talking about testing in production, testing in development, and we're going to talk a little bit about offline in a second. So one of the first things that you do in development is you get new data. And so I want to find out if that new data is reasonable. And so we have something called hygiene detectors. There are 31 checks. We've released 4 just yesterday, 4 new ones, to look at kind of hidden problems in data. And the new ones that we found are like non-printing characters, inconsistent casing, invalid zip codes. And so these things they're sort of ways to look at the data and say, is that right? Is that wrong? Maybe you want to patch the data. Maybe you want to push back. Maybe you just want to let it go on. Another type of what you do again, we talked about this, is sort of testing as part of your CI and CD process. And conceptually here in production, you're running, and I've got this big red-green light. I take production data, I've got my analytic customers, I've got a nice green light here, fantastic. However, in development, you're using test data, and you don't have customers, you have your developers or your data team. And what you want to do is basically say, yeah, you want to have this show up green, that all my tests and all my monitors are passing. I did not break any code. I can safely push to production. That's basically the idea. Having the same sort of stoplight on your data and your tools and your data in development as into production. So what that looks like in let's say a medallion architecture is that I've got coverage. And so this medallion architecture, so first on the left here, this diagram, I've got a development environment, I've got a QA test environment, I've got a production environment. So I'm doing CI and CD here. So the environment itself is a medallion architecture. So I've got a bronze layer, a silver layer, and a gold layer. And then I've got some tools, Airflow, DBT, Power BI, Acting Upon. So I want to have test coverage on all my tables in the bronze and the silver and the gold. And then I want to cover all my tools, Airflow, DBT, Power BI. So again, data is perfect and the tools don't have any errors. And then catching that during production, catching that in development, while you're pouring in test data, that this coverage, adequate testing, adequate tool monitoring, those things give you the red light, green light that you're actually correct. And so just running things like unit tests or eyeing it up is insufficient here. The sufficiency comes from having good test data, good environment. So lastly, how do you improve offline? And so we're getting close to the end here. We got one more section. So one way to get improvement offline is to do data quality dashboards. And our last webinar, we have a new feature on this. And this is a way to judge and measure source data quality. I want to make sure all my source data has changed or is good. Now we have actually a new feature in TestGen. We call it test coverage reports. And I threw out some sort of rules of thumb: 2 tests per column, 2 tests per table, tests across all levels in your database. And so we've have what's called a data catalog, and then that data catalog will show the number of active tests per table. Here's the table, and here's the column. And so this is done by an export. So we just released this. It helps you spot gaps in test coverage. I don't know, one of the things that we'd like to have asked the sort of community of users, do we actually need a coverage dashboard like we have our data quality dashboard in the previous slide? Do we actually need to have a test coverage dashboard? But right now you can do it by doing an export. So that's a good question for people. I'd love to hear your answer. And then lastly, kind of offline, looking at how you run your data journeys. Did they take too long? Is there one that has problems? And then I think lastly, but not least, I think if you're going to have good test coverage, that means you're going to have to sit down and look at when the test failed or when you had problems, and then kind of react to those in a no shame, no blame, love your errors, look for opportunities of improvement. These are very complicated systems, multiple tools, hundreds of data points. And so what you want to do is look at when you have incidents and then reflect and add tests, add more coverage. The whole point here is if you want your test coverage to increase over time, and you want to basically at every point along the way, you want to have meetings called quality circles where you're looking at what's the right improvement I can make to improve my coverage, and do that in a sort of way where you don't have shame and blame. So lastly, what are your design choices? So we've talked about the art of the possible with our open source tools. So where do you start? Well, the first is like, do you have any data quality checks in your data? Do you have any visibility across your production steps? And so I think there's sort of three choices here. Like if you're a data quality, and they're based sort of on who you are. So if you're a data quality person, if you're a sort of a data ingestion engineer or have no control beyond your database, or if you're a data engineering team and you have some control beyond your database. So let's go through each three. The first one is, let's say I'm just a data quality person, right? I'm really focused on trying to improve source data or my L1 data. I want to check that data, maybe develop a data quality dashboard, use that for leverage. And the sort of downstream, all the transform, test, predict, it's sort of, I'm not really focused on that. I'm trying to make our raw data, our source data better. And so that's a great thing, right? And using dashboards, affecting change in this area, it's really important. But it doesn't give you don't have coverage down here. But again, it's better than nothing, right? And this could be, this is a way, and again, improving your source data has the secondary effect of lessening errors in all these systems, but you don't have coverage on them. So the second one is sort of, maybe I just have this dastardly dark database that I control. I don't know what's happening afterward. I don't know what's happening kind of before it. All I can do is look at the database. And so you want to pull that database and then use Lineage to ping people where they may have an error. And so that's great, right? I've got thousands of tables. I use Lineage to say, well, this table is connected to these 10 downstream tables. They're in this report here. They're in this DBT model. I can then ping them to say, hey, look, I found a problem in this data. Is it your model? Is it your report? Can you actually check to see if there's problems? And so that's great, right? And the problem with that is that errors can still get into production, as we saw, right? Because you're polling it, production can happen, and lo and behold, you have a bad report. So the limitation here is you get sort of irrelevant pings, like because Lineage doesn't actually have coverage, you're saying this one table could affect these 10, but which one of the tables actually has the problem? And then it doesn't really help in development very much at all. And so this is kind of where the current data observability vendors, they all share this weakness. But again, it's better than nothing, right? And so, and if you only control your database and have no control beyond your database, this can be helpful. And lastly, I think this is where our focus has been, is sort of getting full coverage across all your data and all your tools. Put kind of tests and monitors as part of the data production process, and then stop on errors before they get into production. And then use that same setup for development testing and test coverage. And our observability and test gen software can help you. So we think this is the right way to go. Again, it gives you full coverage. So lastly, in sum, and this is my last slide. So the lack of test coverage kind of means costs. And costs could mean wasted time, could mean frustration, could mean errors get to production and people are upset. But every problem you find earlier is cheaper. And my co-founder Gil says, tests are the gift you give to your future self. I think that's so true, right? The 1, 10, 100 rule applies. Remember to shift left earlier in the production process and shift down earlier in development. And make sure every table is covered and make sure every tool is covered. And our open source tools, they're free. You can run them on, there's no limitations. You can run them on thousands of tables. Automate the creation of that coverage and also help you quickly build specific business metric tests. And so if you want to learn more, you can download TestGen first, recommend that. Observability, we've got a whole bunch on data ops, And then if you'd like to read or want to share it with your friends, we have a blog on this. So that's it for today. I'll share the slides. I'll share the recording. Is there any questions I can answer for people before I go? I think one, question that we were talking around is like, I think a lot of people are sort of afraid of writing tests. There's sort of, or this question of why don't people have adequate test coverage? And I think a lot of the case is that people are afraid of testing, that it's not part of what they normally do. And their mental model is that it's good to go in at, like I did in the 1990s, and bang on the system and fix it fast. There's sort of the love of heroism, right? And I think that's a challenge for a lot of people. We don't have to be heroes. And so, okay, I'm not seeing any questions. All right, well, thank you so much. Thanks for the feedback on this. Again, I'll send out the slides and the recording in a little bit. Have a great rest of your day.